Boys and girls, welcome back to the ITV Math show. We are busy with optimization. Now, here's a second problem. We're going to do another one or two more examples just to get you working with optimization in calculus. So now they give you a shape that looks like this. You can take the shape down. They give you a big square and they give you an inscribed square within the bigger square. The question says find the area of the shaded part in terms of x. Question number 2, find x giving maximum area. And question number 3, find the maximum area of the shaded part. Now what did I tell you guys when we deal with optimization? The first one, standard formula. Second one, derivative. Last one, substitution. It's generally always done in these 3 steps. Standard form, derivative, substitution. Standard form, derivative, substitution. So let's put it into standard form. Now we need of the inscribed. We need this. So we need length, we need breadth in terms of x and in terms of, they're giving us this one whole side to be 200. Right? It's a big square. They're telling us it's a square. So if that is 200, that is 200. The whole side here is 200. This whole side here is 200. Okay. Now, if the entire side, let's call this A, B, C, D. Now we know AB is equal to BC is equal to CD is equal to AD. Now, what do we have here? We've got this small piece here to be X. We've got the entire side to be 200. Therefore, the small piece here, let's call it A, B, C, D, E, F, G, H. So, if EB is X and CB is 200, therefore EC, the smaller piece here, will be 200, the entire length, minus X. And we know this piece is equal to that piece, so that is X. Now, we know that this is a triangle, a 90-degree triangle. So let's highlight that piece. That is a 90-degree triangle. So I've got the one side, I've got the other side. I need the length of the inscribed square. So obviously we're going to be using Pythagoras. So obviously to answer question number 1, we know FC is equal to X, FC is equal to X. We know EC is 200 minus X. We know that EC is equal to 200 minus X. Therefore we now need to find EF, one side. Because if I find the one side, I found all the sides. So now we need to find EF. And we're now going to be using Pythagoras. Right, so EF squared is equal to x squared. The square on the hypotenuse is equal to the sum of the other 2 squares on the other 2 sides. So what do we have? We got EF squared is equal to x squared plus, we're squaring a binomial here, so 200 squared is 40,000 minus, multiply these 2 and times it by 2, minus 200 times 2 minus 400x plus x squared. So what am I left with? EF squared is equal to x squared plus x squared is 2x squared minus 400x plus 40,000 units, right? That's EF squared. So EF on its own, EF is equal to the square root of 2x squared minus 400x plus 40,000. Now, that is just the length of the side. So that means this here is the square root of 2x squared minus 400x plus 40,000. There we go. That's the length. Now we know that it's a square, so all 4 sides will equal to exactly the same. So therefore area is equal to length times breadth, which is equal to this times itself, which is exactly, so basically it's this squared. Area is equal to the square root of 2x squared minus 400x plus 40,000 squared. Length times breadth, which is exactly 2x squared minus 400x plus 40,000 units square. And there we go. That is the area of the shaded part in terms of x. Question.